Hey, what's up guys? So we're here in Westchester, Ohio at the headquarters for Escort Radar. And I'm here with Dave Smittebush, who is the VP of Product Development here at Cedar. So, hey, how's it going, Dave?
Hey, it's great. It's great to have you here.
Yeah, thanks. Thanks for inviting me.
Look forward to showing you around and having you talk to some of the folks.
Yeah, so with that said, let's go ahead and hop on into the showroom. Let's go behind the scenes at the engineering, take a look at products being built, and see what all goes on here at Escort.
That sounds great.
Cool.
Come on in.
So we are inside now, so we are in the showroom, the front door. So tell us what all we've got around here.
Misty, say hi.
Yep. Hey, Misty.
So this is our Escort retail store.
Okay.
And we've recently expanded over the last year as we've broadened our product categories with all the Cedar products to sell dash cameras and other Cobra products.
Okay.
But the main focus that we sell out of our store is radar detectors because that's the heritage of this location.
So let's go take a look at some of the detectors over here.
So this is really the tech center where we develop all of these detectors. And as you can see, whether it's a Max 360, a Max 360C, a Redline EX, that's really the top of the line in radar detectors, and that's what we sell and service out of this location, as well as all the product development and all of the engineering and a lot of the manufacturing and operations that we'll talk about as we go throughout the day.
Cool. And then what do we have back along this wall here?
So this is really a lot of the heritage that we have with our Beltronics brands and our Escort brands. And so we have products that are still in market. We have products that we're recently rounding out the product lines. And we actually have a nice heritage wall over here too, where we show really the history. It's kind of like the Hall of Fame of radar detectors, where it's the history of Escort over time.
Okay. So yeah, come take a look at this. This is cool. So we've got everything from the original Escort over here, 9-volt Passport, we've got the Escort DSP, and the original Solo, and these ones are tiny down here. I've never seen them in person being this small. And then down here we've got, again, the whole lineup of all the Passport series detectors all the way up to the 7500 down on the bottom right.
And then we take over with the 8500 and so forth, the more newer models for both Escort and Beltronics up on the wall. So it's a great showcase for customers coming in, and then over at the counters where we're actually selling all of our newer products.
Okay, this is cool. So yeah, a lot of the current stuff. So Passport 9500iX, the Redline, of course, Solo. So this is a lot of current stuff. And then we move back over here and we've got some of the older Beltronics units, which is cool to see too. So Pro 200, Pro 100, 300, 500, the Magnum. This is cool. So yeah, a lot of the products that you have on display all right here.
Yep. It's a great showcase for customers to come in.
Yeah, cool. And with that said, well, let's go behind the scenes and take a look.
Let's go do it.
Cool.
So Ariel, let me show you a couple areas of history for Escort here if I can. So if you look down the hallway, we actually document some great events that happened in various years throughout the history of our company.
Okay.
And what's really nice is there's the passion of the employees, making sure that they're signing their name to everything we're doing and pointing out some great history. This happened to be from the 2010 calendar year where we introduced 3 or 4 new products. So it really shows the passion that the employees have in terms of really trying to listen to the customer and produce great products.
All right, so next we're here in the production line with Tyler. Hey, what's up, Tyler?
How's it going?
So show us kind of what you're working on and what you're basically making here.
Yeah, so it all starts over here. We program the actual main boards right here on this machine. And then, after the antennas are all put together and assembled, I will begin soldering wires onto the main board, like so. And then I will take the antenna and I will attach it, and we will get our final product.
Oh, cool. Okay.
Which then goes to the RF test, and if everything works out, it'll pass and it will be put into a car.
Awesome.
Yeah.
So next with the MaxCI testing, we've got Jeremy here. Hey, Jeremy.
Hi, how are you?
Good, good. So tell me a little bit about what you're working on and what the testing process is like.
This is a MaxCI XCI, and it requires an M4. We got the GPS, you got the light, LED light, you have display, which is right here. Then you have the control module. And also you have, like I said, this is the front receiver of the M4 for the IXCI. And then we have the power source, which we'll just go ahead and test it here.
Fire it up.
Then I'll just go through the display, make sure everything works properly, and then go from there. So I'll go to preferences, always test in highway mode. That's where you get the most sensitivity from the units.
Preferences. Pilot mode. Speed. Speed alert. On.
Make sure that the volume corresponds with what I'm pressing here.
Meter options. Standard.
Test it in spec.
So you're basically going through all the different menu options and buttons and just making sure everything works as it's supposed to.
Yes, sir.
Auto
Okay,
mute.
makes sense.
Media on.
And then, like, what else do we have set up here? Or, like, what do you do once it's all finished testing? And looks
Once
good?
it's all finished testing, it'll actually go to shipping and receiving,
Uh-huh.
and that's basically it.
Cool. Great, thanks. And here's a bunch of Max 360Cs. As you can see, they're all in the quality control stage, so they're basically going through the final checks. But as you can see, they got a whole ton of them here. Now, next up is the customer repair area. So basically, when you have a problem with the detector and it needs to be repaired, they have a whole section set up over here just to take a look at the detectors, to disassemble them, test them out, and put everything back together for us. And we've got Pat over here. Hey, what's up,
Hi.
Pat?
How's it going?
And he's actually working on something he can show us to give you an example of like a repair in action. So what all have we got here?
Okay, well, I'm kind of responsible for a lot of the processes that go on in our manufacturing cell.
Okay.
So whenever they have some unusual problems or fallouts there, I'm the guy that they call to investigate if there's a process problem, material problem, that sort of thing. So today we've had an issue with some screws breaking off in this antenna when we try to assemble it to the board.
Okay.
So I've just been back in the engineering area and I've pulled some fresh units off the shelf that haven't been assembled yet. We've been inspecting them with pin gauges to find out if the casting holes are undersized or not. Try to find out why we're breaking screws off.
Perfect. Cool. Thank you.
You're welcome.
All right, and so now we're here with Jason, and he's doing some testing, some components of the radar detectors, right?
That's correct.
Cool. All right, so show us what you got here and what you're working on.
So right now I have a circuit board here sandwiched in between a test fixture.
Okay.
And what I'm doing is I'm measuring the performance of the circuit on a piece of test equipment called a network analyzer.
Okay.
This particular circuit is a front end section for a radar detector, and it covers both the K and the KA band.
Okay.
This is a product improvement for the M3 program.
Okay. Cool. And then, so what are we actually taking a look at here on the screen, and what's running through the system?
So the screen shows a frequency response from 10 gigahertz to 40 gigahertz, and basically this particular circuit is supposed to give us a nice response at the K band, and then also a nice response at the KA band. We're looking for some gain here,
Okay.
and we're looking for some rejection at a given frequency.
Got it. Okay. Cool. Thank you. And then I guess the last thing. So what do we have exactly here? Can you kind of walk us through exactly what you're showing?
Basically, we got a coax cable coming into a test fixture. We have the circuit board itself. We have an LNA followed by some image filtering, and then a network that brings us back to a coax cable.
Perfect. And that's what you are taking a look at here on the screen.
That's correct.
Awesome. Thank you. All right, so next we're here with Sean in customer service. So hey, how's it
Hello.
going, Sean?
Hi.
So tell us a little bit about what you do back here and what it's like on the customer service end.
Oh gosh, we help customers all day long via phone calls, via chats, via emails, answer technical questions, set up repairs, help customers decide which products to buy, do all of those things that you do in a customer service department.
Cool. And how busy does it get back here? I'm sure it
Very,
varies. Yeah.
very. Seasonally, it's incredibly busy. Other times we have a little bit of lulls where it's a little bit slower. So it just depends.
Cool, thanks. And then so we've got, I guess, a number of different people back here.
We do,
and-
we
Yeah.
do.
Is it okay to take a look around?
Yeah,
or?
sure.
Yeah, sure.
Come on back.
Sure.
This is us helping customers every day,
There we go.
This
On
is
the
what we
phones,
do.
Doing your thing.
right?
Hey, everybody. Yep, I know they're busy. I don't want to talk too loud. We have
Yeah.
phone conversations.
I think,
But yeah, this is cool. That's where it all happens behind the scenes.
yeah, this is it.
Great, thank you. Now, unfortunately, we actually ran out of time as we were going through the tour. The interview itself, we covered quite a lot, and it took a lot longer than we had anticipated, and so we didn't have enough time to go through everything on camera, which is kind of unfortunate because it turns out there's a lot of really cool stuff here. It actually walked around a little bit just to kind of meet everybody and get familiar with it before we started going into everything. And there's things like the prototyping and development for the different components they actually design here in-house, and then go out and have it made, brought in, and there's so much cool like testing and development and fabrication of all the detectors and how everything is built. Like, I really would have loved to show that with you guys, because talking with the engineers and stuff, there's so much cool stuff that happens here that I didn't know about, and it's kind of a bummer that I wasn't able to show that to you. But yeah, everything as far as like technical details and LNA discussion and all sorts of fun stuff, how the stealth technology is designed, the components that they put in and how things are built and magnified on screen, and just tons of really cool stuff. So anyways, yeah, I wish we had more time to kind of go into details here. This place, I guess from the street you can't really tell, but it extends pretty far back and there's a ton of stuff going on. So yeah, customer service, the Max CI 360s, those are the ones that are built here and then shipped out. Everything else, it seems like it's made elsewhere, but the assembly and everything for the, it's like the IXCI, that's also made here too. But anyways, yeah, it was cool to take a look at this place. Thanks so much for Escort for inviting me out. Other than that, it was pretty cool to see. Hope you guys enjoyed getting to meet a number of different people here at Escort and take a look around and see kind of some of the behind the scenes stuff as far as what happens at Escort. So awesome. Hope you guys enjoyed this. Thanks for watching, and I'll see you in the next video. Bye. So now we're going to be doing some radar detector testing with Jason. So hey, Jason.
How you doing?
Good, good. So tell us where we are and what we're looking at here.
So right now we're in a screen booth. Right now I'm evaluating a circuit that's for product improvement on the M3.
Okay.
Basically, I'm looking at a packaged front end, LNA and filter. On the screen here on the network analyzer, you can see that there's a frequency response for both K and Ka band with an image filter in the middle. These particular two bands have, one's a high side injection, one's low side injection, so the image frequencies fall in between. So this structure on this PWB here gets rid of the image frequency. All receivers basically take a frequency and down convert it to a lower frequency. They do this by injecting an LO into the mixer. One of the issues that receivers have is that the image frequency is a certain distance away from the desired frequency, and what happens is it mixes to your baseband and it reduces your ultimate sensitivity level, from anywhere from 6 to 12 dB. So what we do is we put an image filter in the design to reduce the image noise from folding into the IF bandwidth, into the detection bandwidth, if you will.
Okay.
So basically, this circuit here is basically, it has two pass bands. This section for the Ka band's a little bit undercoupled, so we're working on that to make the coupling a little bit better there.
Okay.
But basically, it's K and Ka band.
And so when it's coupled, what would that help us accomplish?
So basically, the structure on the board, one section to the next has to agree with each other. So coupling is how one section connects to the next section.
Which will then give us better performance?
Well,
when
no,
everything matches?
it'll change the shape of the filter here. So we want the
Okay.
filter to be a nice square shape. We don't want it to be undercoupled there. But,
Got it.
But basically, this is just a test fixture, a network analyzer. So this piece of test equipment sends out a signal and looks at what signal it receives over here, and then vice versa. So it sends signals back and forth, and then inside this box it has a bunch of couplers and whatnot, and it basically prints out the frequency response of the circuit at hand. So basically this is an LNA powered by a power supply.
Cool. And then so actually taking a look at what we have here, we basically have an LNA on a board, and that's what you're tying into. Is that correct?
Yeah, basically there's RF coax connectors here on both ends, circuit board in the middle. There's an LNA, there's some filtering, which in this case is the image filtering, and then basically there's two coupling, there's an input coupling and an output coupling section on the board.
Okay, cool. Thank you.